In this video, we're going to find the derivatives of sine of x and cosine of x. First, we will show that the derivative of sine of x is cosine of x. Before the proof, let's verify that this checks out visually by looking at the graphs of sine of x and cosine of x. So up above here's sine of x, and let's think about, what's the derivative of sine x when x is equal to 0? So the derivative with respect to x of sine of x evaluated when x equals 0. Well, we see that there is, that this line has a positive slope, and it's a positive slope. Could it be 1? Could the derivative at x equals 0 of sine x be 1? Yeah, like 1 seems okay. That seems reasonable. What else might we want to look at? What about the derivative when x is equal to pi over 2? So this is pi over 2. When x equals pi over 2, yes, that is a horizontal tangent line. So the derivative of sine of x evaluated at x equals pi over 2 is in fact 0. And that checks out with the value of cosine of pi over 2. And again, this also checks out with the value of cosine of 0. So far it looks like these things could match. It's certainly not a proof, but just a visual assurance that this looks like it could be reasonable. Now let's look at what about when x is equal to pi. So now the slope of this tangent line is negative. Could the slope possibly be -1, as that's equal to the value of cosine of pi? That seems reasonable. It's a negative slope. It could be a slope of -1. And so it could potentially be the case that the derivative with respect to x of sine of x evaluated at x equals pi could be -1. It's certainly a negative value. And that would be equal to cosine of pi. So far this is looking pretty good. It looks like the graph of sine of x, if we look at the slopes at each point, if we look at the slope at any point in that graph, that could reasonably be, so here we've got a positive slope, and that's a positive output, and so on. Any point where there's a positive slope, we're seeing a positive value for cosine of x. Anytime we are seeing a slope of 0, we've got a value of 0 for cosine of x. So basically cosine of x could be the derivative of sine of x from what we are seeing. Now let's prove that that is actually true. So recall that previously we proved that the limit as theta goes to 0 of sine of theta over theta is equal to 1. So we proved that previously. We're going to use that in the proof that the derivative of sine of x is cosine of x. We're also going to use a couple of trig identities to prove this. And we want to first show, in order to help us do the overall proof, that the limit as h goes to 0 of cosine of h minus 1 over h is equal to 0. And to prove this, we are going to need a trig identity, and the trig identity that we're going to need is this one over here. It's called the double angle formula, that cosine of 2 theta is equal to 1 minus 2 sine squared of theta. So we're going to use that to prove this, and then we are going to use both of these things to prove that the derivative of sine of x is cosine of x. All right, so looking at the limit as h goes to 0 of cosine of h minus 1 over h, we are going to rewrite that equals the limit as h goes to 0 of using this double angle formula, cosine of h, we're going to let h be 2 theta, and then theta is equal to h over 2. So this is cosine of h is equal to 1 minus 2 sine squared of h over 2. And then that was all cosine of h, and we still have a minus 1, all divided by h. So that's equal to the limit as h goes to 0, the 1's cancel out, of negative 2 sine squared h over 2 divided by h. And we can rewrite that as negative limit as h goes to 0 of, so we can multiply the numerator and the denominator by 1/2 times, and we're going to break up that times 2 times, we're going to break up the sine squared into sine of h over 2 times sine of h over 2, just breaking up that squared into the product of itself. And so that's equal to negative limit as h goes to 0. So now this 1/2 and the 2 cancel out, and we've got sine of h over 2 divided by h over 2, 1/2 h, times, now we're going to break up this into the product of two limits, and we know that the limit of f times g is the same as the limit of f times the limit of g, so we're breaking this up, times the limit as h goes to 0 of sine of h over 2. And so now we've got negative limit as h goes to 0 of sine of h over 2 divided by h over 2. Well, if h over 2 goes to 0, then, if h goes to 0, then h over 2 also goes to 0. So what did we prove? We proved previously that limit as theta goes to 0 of sine theta over theta is equal to 1. So all of this reduces to 1 times. Now what's this limit equal to? Limit as h goes to 0 of sine of h over 2. That's sine of. Now this is defined. We can plug h equals 0 into sine. So this is 0 over 2. And so that's equal to negative 1 times sine of 0, which is 0. And so that is 0. So we have proved that the limit as h goes to 0 of cosine of h minus 1 over h is equal to 0. All right, so we know that the limit as h goes to 0 of sine of h over h is equal to 1. We know that the limit as h goes to 0 of cosine of h minus 1 over h is equal to 0. We're going to use one more trig formula, which is this one, this addition formula, to find the derivative of sine of x. So by definition, that's the limit as h goes to 0 of sine of x plus h minus sine of x, all divided by h. Now we're going to use the addition formula to say that that is equal to the limit as h goes to 0. So here x is going to be the a in this formula, h is the b in this formula. So that's sine of a, that's x, cosine of b, that's h, plus cosine of x, sine of h, and so that's all sine of x plus h expanded using the addition formula, a trig identity, minus sine x, so that's still up there, all divided by h. And now this is equal to the limit as h goes to 0. Let's do some factoring of, let's factor out a sine of x. Sine x times cosine of h is the first term that has a sine x in it, and just negative 1 is the next term that has a sine of x in it. So that's taking care of those two terms, plus cosine of x, sine of h, all divided by h. So continuing on, that's equal to, now let's break up this limit. We know that the limit of the sum of two functions is equal to the sum of the limits. So this is the limit as h goes to 0 of sine of x times cosine of h minus 1 all over h, plus the limit as h goes to 0 of cosine of x sine of h all divided by h. Okay, so observe that sine of x does not have an h in it, so it is constant with respect to the limit. So this is equal to sine of x times the limit as h goes to 0 of cosine of h minus 1 over h. And similarly, cosine of x is constant with respect to h, so cosine of x times the limit as h goes to 0 of sine of h divided by h. And now this is equal to sine of x times limit as h goes to 0 of cosine of h minus 1 over h, that's what we just found, is 0, plus cosine of x times limit as h goes to 0 of sine of h over h we know is equal to 1. And so we finally had that this is equal to sine of x times 0 is 0, plus cosine of x times 1 is cosine x. So this is cosine x. And we have shown that the derivative with respect to x of sine of x is equal to cosine of x. We will now show that the derivative with respect to x of cosine of x is equal to negative sine x. And we are going to show that using the limits that we have above, as well as this addition formula, cosine of a plus b. So by definition, the derivative with respect to x of cosine of x is equal to the limit as h approaches 0 of cosine of x plus h minus cosine of x all divided by h. So that's equal to the limit as h approaches 0 of, now using this addition formula, cosine of x times cosine of h minus sine of x sine of h all divided by h. And so that's equal to the limit as h goes to 0 will do something, and we still have this cosine of h here, so minus cosine of x, don't forget that, so minus cosine of x. And so we're going to do something similar. We'll take the limit as h goes to 0, and we're going to factor out a cosine of x. So cosine of x times cosine of h is the first term that has that, cosine x is the second, so minus 1, minus sine x sine h, all divided by h. And so again, we're going to break up this limit. This is equal to the limit as h goes to 0 of cosine of x times cosine h minus 1 over h minus the limit as h goes to 0 of sine x sine h over h. And again, we can observe that the cosine of x is constant with respect to h, so we can bring it out front of the limit. It is not affected as h goes to 0. So cosine of x times the limit as h goes to 0 of cosine of h minus 1 over h minus, and same thing with sine of x times limit as h goes to 0 of sine of h over h. And now we've got cosine of x times limit as h goes to 0 of that quantity we proved is 0 minus sine of x times limit as h goes to 0 of sine h over h is 1. And so that reduces to negative sine of x. And we have proved that the derivative with respect to x of cosine of x is equal to negative sine of x. So let's just do a quick example using our previous derivative rules. So the derivative, for example, of 4x to the 5th minus 3 cosine x plus 4 sine x. So we can use power rule, constant rule, sum difference rule, etc. This would be by the power rule and the constant multiple rule. 4 times derivative of x to the 5th is 5x to the 4th minus 3 times, using the constant multiple rule, times the derivative of cosine x is negative sine x. plus 4 times the derivative of sine x is cosine of x, and so that's equal to 20 x to the fourth minus a negative 3, or negative 3 times a negative is plus 3 sine of x plus 4 cosine of x.